Welcome to Circular Concrete Silo Math. Okay, we have a problem here. We want to find some volumes of concrete that we need to be able to build this kind of silo. And let's have a look at our drawing first. Always good to first check what we even have, what can we find out to get a good idea of what we're dealing with. So silo means we're dealing with circles. And we have a concrete circular wall around the outside, and then we have space in the inside to store something. Then on the side here is a detail or a cross-section drawing where we can see how the concrete wall is actually built. So we have a footing. You can see it's 600 mils wide, 200 thick. We have a concrete wall. You can see that it's 4,200 mils high, 200 mils thick. And then we have a slab on the inside. So that gets poured on the inside after we've built our walls as a floor for whatever gets stored on top. So we can see that the slab here is 100 mils thick and it's 100 mils off of the footing here. Then another thing we can find out is the diameter to the very outside of our wall. That's important to note always to see where those arrows go to. Then on here, we can see the kind of things we're supposed to find. So CLP, the center line perimeter, that's a normal thing to find in concrete things. And what that means is the center line of our wall right here, all the way around. We want to find out the volume of the wall. We want to find out the footing volume. Then we want to find the area of the slab. So that's on the inside, right? Because it butts into the wall on the inside. Then we want to find the volume of the slab. And then if there was a question to say how much total volume of concrete do we need to buy, then you would just add all of them together. And at the end, we want to find the volume of the silo itself. So how much can we store inside? First thing I always do when it comes to circular things or really any math is to write out the main equations that I need. Just as a reminder right in the beginning so I don't get confused later. So one thing we're going to want to find is the circumference, right? Kind of for the center line perimeter, because really that is the circumference of a circle. So C equals 2 pi and then R, our radius. And we're going to find a few different radii here that we can use for our math. And then the area for any circular things is pi R squared. There you go. And I just leave them at the top as a reminder for myself for later. So what do we already know? We want to find the radius of the outside wall. So when we look here, we have a diameter, and the diameter is always twice the radius. So the diameter goes from the outside to the outside, but the radius is just exactly half, right? The radius goes from the center to the outside. So 3,800 divided by 2 will give us the outside wall radius of 1,900, and I'll just pop that in here, 1,900. And you can always highlight things in different colors and write them in as it works for you. Then something else we're going to need is the radius of the inside wall. Why do we need that? Well, later on for our slab, it goes to the inside of the wall. And we're going to need the radius for that then. So inside wall is our 1,900, right? That goes all the way to the outside. And then we want to subtract our thickness of the wall right here. And that will get us to the inside, right? The outside radius goes to the outside minus the thickness of our wall will get us to the inside here. So minus 200, and that gets us to 1,700. Awesome. Then we're going to need one more. We want the radius of the center line, right? As I mentioned before, the center line perimeter runs along the center line of our silo. So we need to find the radius from the center to our center line. And that's how we can figure that out. So from our 1900, we want to just subtract half of the wall thickness. So 1900 minus half the wall thickness, so minus 100, gets us to 1800. And there are, of course, always various ways that you can figure this out if you want to deal with the diameter minus a full wall thickness, that kind of thing. But it should all get you to the same at the end. So let's start figuring some things out. So first we want to find our CLP, our center line perimeter. And I've written it out up here. The circumference of a circle is 2 pi r, and we want to use the r of our center line. Right, so then plugging that in, 2 pi, and it's our 1800. And I'm going to start turning this into meters here just so we don't have so many zeros and get confused and have to punch too many things into the calculator. So take out your calculator, do it with me. 2 times pi times 1.8 should get us to 11.310. 11.310, and that's meters. 11.310. Often, as I'm doing the math, I'm not adding meters or millimeters as I go, but at the end, it's nice to add them so that you're aware whether it's meters, square meters, or cubic meters. Okay, so let's move on to the next one. We've got our center line perimeter. Now we want to find the volume of our wall. So volume of the wall. Well, any volume, how do you do that? Length times width times height. So we have the width and we have a height. What's our length? Well, the length is the center line perimeter that we just figured out. So it's our center line perimeter times our width times our height. And I always encourage students to write it out every single time. The more you write it out, the more you understand it, the easier it'll get. And the better you can understand why you're doing something the way you're doing it, just makes it easier to remember as well. So our center line perimeter, that's a number here that we want to continue to use. So 11.31 times our width. It says 4,200. So turning that into meters, 4.2. Oopsie, and that's our width first. So I'll keep that the same width. Sorry, so 200 mils. So 0.2 times our height of 4.2. And that's all meters, right? And punching that into the calculator, 11.31 times 0.2 times 4.2. Comes out with 9.5 meters cubed, right? Because we're finding a volume, we're doing meters times meters times meters. So 9.5 cubic meters of volume and of concrete, of course. Excellent. So now we move on to the volume of the footing. Volume footing. And again, it's always nice to write out what it is you're actually trying to find out. So you know when you have to restudy for it or refigure something out from a problem you've already solved for a different problem, then you can easily retrace your steps. So footing works exactly like the wall. We have our length times width times height. So we have our center line perimeter as our length. We have our width. And we have our height. And I'm just going to call it thickness here because to me that makes more sense, but it is exactly the same thing. Right? We have our width and our thickness right here, and the center line perimeter is the same as we've already figured out. So 11.31 times our width is 0.6 times our thickness is 0.2. Punching it all into the calculator. 1 times 0.6 times 0.2 gets us 1.357. 1.357 0.7 cubic meters. So that is the amount of concrete we need to buy for the footing. Now, the next one is the area for the slab. So A for area, and we want to figure it out for the slab. So remember that the slab only goes to the inside of the wall. So we need to use the radius of the inside wall, that one up here. How do we figure out an area again? Well, good thing I wrote it up there. It's pi r squared. Pi r squared, and it's the radius of our inside wall. Plugging that in, so pi times our inside wall is 1.7 squared. And for this type of situation especially, I try not to put in the meters or millimeters or whatever we're working with, because you might just misread it as already being 1.7 meters squared rather than squaring the 1.7 number itself. So popping that into the calculator, pi times 1.7 squared comes out with 9.08. And that's square meters because we're multiplying meters by meters, which gets us squared because we're doing an area. So slab area, 9.08 meters squared. Awesome. So from here, when we want to find out the volume for the slab, well, we already did half the work here. Again, how do we figure out the volume of anything? It's length times width times height. And for a circle, length times width is the area of the circle itself, right? And then we multiply it by the height that we have given to us right here. So we take the area of the slab that we just figured out and we multiply it by the thickness of the slab. So 9.08 meters squared. Thickness is 100 mils, so 0.1 of a meter. 9.08 times 0.1 makes sense that it comes out at 0.908 cubic meters. 0.908 cubic meters. So at this point, if there was a question to say how much total volume of concrete do we need to buy, you could just add up your slab volume, your footing volume, and your wall volume. If then the question is we want to round up to the next cubic meter or to the next half or quarter, then you would multiply it by the multiplier. So either round up, yeah, whatever it may be. So now we have one more to do, the silo volume, and I'll pop that down here. So volume, silo. Now, this is where we want to find out the volume, not of concrete, but the volume of goods that could fit inside our silo, right? So we want to work inside to inside. And well, do we already know the area of what is happening inside the silo? Well, yeah, we do, right? We figured out the slab area. So now to find out the volume, we need to use our area of the slab, what we found here, and we need to multiply it by our inside wall height, right? We can't use our outside wall height because it goes down all the way to the footing. But if you look closely here, our slab sits up from the footing a little ways. So we just need to adjust that number. So we take the area of our slab times our inside wall height to find that. So area of the slab, we already figured out 9.08 meters squared times, well, let's have a look here. Inside wall height from the outside is 4,200 or 4.2. And we have 100 mil space and then 100 mil slab. So 4.2 minus 0.2 gets us to 4 meters. Punching that into the calculator, 9.08 times 4 gets us to 36.32 cubic meters of whatever we want to store in there. And for that worksheet, this is it. So just to do a quick recap, I always write out my equations for the problem that I think I'm going to need, just so if I move on and I lose my brain a little bit, I can always refer back. And it very clearly says circumference and area, just so I don't confuse myself later. Then we need to find our different radii. So radius to the outside wall is kind of our starting point. Then we need to find out our inside wall radius for everything relating to slab and inside of silo volume. And then we also need our radius for the center line, the CLP, which runs down the center of our whole wall construction, because that's what we're going to use to calculate our volumes for the wall and the footing, just like in any other concrete math. And I suppose we could write that in here too, 36.32 cubic meters. And then just keep good track of what you're actually trying to figure out. Always write out what you need, volume, always length times width times height. And for the slab and the volume of the slab, remember that we need to work with the inside radius and as well for the volume of the silo because it needs to fit inside. And this is how she goes.